Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany. They're coming back to the Zurich International Airport. Runway 1449, let's localize our landing. So now in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start sharing the cockpit instrument that explains the functions of the Boeing 787-900 jet aircraft. I'm going to start with the primary flight display. The displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the vertical rate of climb less than the aircraft in tens, hundreds, and thousands feet per minute, or the stiffness of the chronometric angle since previous intent to climb in descent. We have also the barometric pressure of the atmosphere and the barometric altitude, target altitude selected from the autopilot flight director system panel. We have also the artificial horizon with the attitude indicator, the pitch ladder in degrees and the back angle in degrees. The Lszh localizer, we have the horizontal localizer and the vertical glide slope display that displays the radio frequency received from the transmitters of the airport we use for takeoff and for landing, and help us to align with the horizontal and vertical profile of the aircraft as it approaches for landing. So we have the display of the horizontal and vertical localizer and the vertical glide slope from the onboard receivers of the aircraft for the instrument landing system. So we're gonna have the Zurich International Airport LSDH and runway 14 Lszh localizer frequency for this purpose. So we have also the Lszh localizer crossbar. We have the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies on the flight mode and zero, the autopilot and the autothrottle. Later on, vertical navigation modes. We have also the HSI that displays the horizontal situation indicator with the magnetic heading and track, and the instrument, the decorated display of the flight plan. We're gonna create later using the flight management computer. So we have the navigation display that displays the horizontal and vertical profile of the aircraft as it flies. You can see also the flight one in the horizontal and vertical profile. We have the terrain and weather reflections from the weather radar. You can see with red, green, and yellow the display of the terrain around you, and also in a horizontal and vertical profile. And also you can see the terrain map with the airports. The airport that we are located right now, the Zurich International Airport, the Lszh is in Switzerland with its name, 4-letter code name. Also the runways we're gonna use for takeoff and for landing. The taxiways, we have a GPS display. So we have also the magnetic North Pole and its North Pole, the geographic North Pole and magnetic variation depending on where we are in the world. We have the display of the navigation names that navigates the ADFs and DPs, the work stations, and the waypoints. The waypoints, which are horizontal vertical navigation fixes the aircraft we're gonna have to transverse to as it flies. Some waypoints we're gonna select these in the flight management computer when we create the flight plan. So you will see all this how we're gonna create the flight plan, how we're gonna fly the aircraft in the current part of the video. Flying manually the Boeing 787-900. So you're gonna see first all the systems and explanation and for each system, and also make an engine start demonstration before flight. So you're gonna see also as I telling you the navigation display, what more it displays, like the ground speed, the wind direction and speed. You can see the distance of the terrain map and the objects where they are located. You can see other aircraft that fly around our aircraft. You can see using the TIC system, the traffic collision advisory system, that use the transporter of the aircraft, the DSP transmitter receiver, and a DSP and ADSC transmitter receiver. The transporter transmits our frequency to other aircraft and the air traffic control and receives from other aircraft, and its computer can calculate the other aircraft distance from our aircraft, horizontal distance, also the altitude difference from our aircraft. where do they climb or descend with respect to our aircraft. So the altitude difference will show you if they are higher or lower, how many feet above or below you they are, and also you can calculate the velocity between your aircraft and the other aircraft. This way can give you a warning if we have an incoming collision with another aircraft, and the air will give you the PICA system advisory in the primary flight display and the navigation display. So you will see all these things. Also you will see the flight management computer. You'll see the flight controls over here. I use the flight controls to control the aircraft for climb and for descent, for making turns to the right, to the left, using the thrust levers. Also you'll see the engine thrust produced over here, displayed in the ACAS engine indication control system display over here. So you can see the engine's indications. Now we will move all the thrust levers around. You can see also the displays here, the primary flight display with the flight mode annunciator over here, the HSI down here, the navigation display, the horizontal and vertical profile, the flight management computer down here, the autopilot and flight director system panel over here, the systems display. You can see the electric, hydraulic fluid system, pressurizer, all systems that are located in the overhead panel over here. You can see also digital format. There I'm gonna show you how. We have also the display of the barometric altitude setting, for instance over here inches of mercury, hectopascals, radio baro, and the plan, the range, with the radar traffic terrain on the display. So you can select some modes and some functions of the displays over here. Also accept, cancel, reject some warnings and cues, and also so you can see in the primary flight display we have the airspeed indicated, the airspeed tape in the left side. You can see the airspeed indicated is 30 knots, and the airspeed selected from the autopilot flight director system panel displayed with purple or magenta. Also the altitude here, the altitude tape, and the altitude selected from the autopilot flight director system panel. Right now we are 1430 feet in the Swiss mountains over here in the Switzerland airport, 1430 feet above the sea level. So you can see the barometric pressure setting for that, 29.92 inches of mercury, landing altitude, radio minimums, radio altitude above the ground level, the vertical rate of climb descent of the aircraft in 100,000 feet per minute. You'll see this needle moving up when we climb, moving down when we descend. Pitch ladder over here in degrees, 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 for pitch up or pitch down. Also the bank angle in degrees, flight mode annunciator, takeoff, ground, both horizontal and vertical mode. So you will see also more information here in the display when we create the flight plan. You can see also the aircraft, where it's located right now here in the mountains. We can change the range. Right now the range is the terrain elevation also 4800, 048 and 015. We have the map in the display. The range right now is 80 nautical miles over here. Ground speed is 0, track magnetic north pole heading. So you will see a few more information about these things. Autopilot flight director system panel. Later you see same airspeed, heading and altitude, like the values selected and displayed here in the primary flight display, both sides. You can see airspeed and altitude selected, and also heading over here selected 360 degrees or 0. Also the altitude we have selected 10,000 feet. It's also displayed in the vertical profile. We're gonna be flying. You will see we're gonna select a higher altitude for flying. You will see the aircraft flying above the terrain in front of it. So we have a few more minutes before going into flight. We'll show you a few more things over here. Also the outside view of the aircraft. As I told you, the flight controls, the flaps, the slots. We have too many functions to show you about the aircraft, the Boeing 787-900 before going into flight. So we have also so we'll create a flight plan. So we're gonna use the takeoff gross weight of the aircraft. Also you have it's gonna calculate using the fancy computer the minor aerodynamic chord position of the forward wings, the Mach, the center of gravity, the horizontal trim stabilizer for takeoff. So I will talk to you now a little bit about aeronautical and aerospace engineering and aerodynamics. We need also for flying the aircraft some principles about Newton's and aerospace engineering. So you will see Newton's physics and Bernoulli theory of fluids. You can see the outside view of the aircraft. You can see when we fly the aircraft, wings hold the weight of the aircraft, the surface area of the wings, of the forward wings mainly. So we have the thrust vectors from the engines, we have the minor aerodynamic chord position, the Mach is about 23% over here, where the maximum aerodynamic lift occurs in the forward wings is also the position where the stall, the airflow will become detached when we fly. We have also the vertical axis over here, the center of gravity. Very much where the minor aerodynamic chord is. We have also the deflections from the flight controls when we move around the yoke of the Boeing 787 or the side stick of the Airbus aircraft. You have pretty much the same functions. So you can see we can use the elevator that transverses the lateral axis, the pitch axis of the aircraft for climb and descent from wingtip to wingtip. You can climb and you can descend. We have the yawing axis that transverses is the vertical axis for making yawing turns left and right, and also we have the rolling axis for making turns left and right like this, left turn and right turn, using the ailerons and the spoilers on the left and right wing and the flaperons, as you can see. So this is the rolling axis, this is the longitudinal or rolling axis, the vertical and the lateral, the pitch axis for climb and descent. So this axis also we have the horizontal tail trim stabilizer over here. The horizontal elevator, we can trim it when we fly, trim up and trim down for balancing the aircraft, also for relieving the air pressure from the flight controls from the yoke, or as I will show you later. So we have also the wings of the aircraft. You can see the bottom surface of the wings is more flat. Also we have the flaps extended fully over here. You can see the flaps, also the speed brakes extended like this. So you can see the bottom surface using the Bernoulli theory of fluid. When we're gonna be flying, we have an angle of attack like this. It's gonna be moving slower. We're gonna have slower airspeed below the wings, which is gonna pressurize the aircraft wings below. We're gonna have higher pressure, which is gonna pressurize the aircraft weight and wings up into the air. So we have higher pressure below the wings when we fly. Also, you can see the top surface of the wings it's more curved. There is a higher curvature above the wings. So using Bernoulli theory of fluids, the airflow moves faster above the wings. So there is lower pressure, which sucks the aircraft weight and wings up into the air. So that's the basic aerodynamics, aerospace and aeronautical engineering and Newton's physics. Bernoulli theory of fluids, all we need to know for the air transport pilot license. So you can see also here. I'll show you now the flight controls, perhaps how to use them. So I'll show you how to use the Boeing 787 its flight controls for climb and descent. You can see we use the vertical column. It's for climb and for descent, for moving the elevator up and down. We have free movement. Both sides are interconnected, the captain and the first officer. They don't move independently for each other. They move together, all flight controls. So both yoke rudder pedals and control wheel and control column. So you can see we can use them to change the direction of the aircraft in flight. For climb and descent, we have the elevator like this. You can see climb and descent. So this is climb, this is descent. Quite easy, very fast. Also left and right the rudder pedals. Again climb like this, descent. Also we have left and right turn like this, as I showed you before. And I'm gonna show you the inside again. So we have full flight controls movement. We have the horizontal trim stabilizer over here, the switches. I will show you what the horizontal trim stabilizer is doing. We have the thrust levers. As you can see, we can move the thrust of the engines forward and aft. I'm gonna show you also the flaps and the slots and the speed brakes. Also in the rudder pedals we have the nose wheel steering, the tiller interconnected and ground at tilt summer speed, like from 0 up to 45 knots. It's decreasing from 76 degrees to 7 degrees. Then from 45 knots, like 70 knots, decreases to 0 in takeoff. And then we have only the rudder aerodynamically effective above 45 knots and for takeoff. So you use only the rudder after summer speed in takeoff. Maybe like 70-80 knots after, it's only rudder, no nose wheel. So you will see all these things. You can see the horizontal trim stabilizer over here I'm talking about. We can trim the horizontal tail of the aircraft, trim up this way, as you can see. You can see elevator trim. Elevator trim, left click down, right click up. You can see where it's located, you can see how I use it like this. We have also autopilot disconnect over here and head up display declutter with declutter. So we use this to trim up and trim down the horizontal tail of the aircraft, the elevator as we fly. We have also the alternate pitch stream over here. You can see alternate pitch stream channel. Because it's a fly-by-wire aircraft, you trim up the nose this way, pitch up nose, and pitch down nose this way, the nose of the aircraft. But actually trim the elevator or the horizontal tail to give that effect in flight. So you have nose up this way, nose down, alternate pitch stream channel, as you can see. We have also the parking brakes here. As you can see, we have the stabilizer trim cutoff switch. You can see some functions from the radio, navigation radios. So we have the stabilizer trim cutoff switch. This red carded switch. If you have a small function of the fly-by-wire channel of the autopilot and flight director system panel and the auto throttle. Since this is a fly-by-wire aircraft, you have a failure that affects the left and the right, or the left and the right horizontal stabilizer or elevator hydraulic systems. You can see the hydraulic system pumps here, the engine driver and the electric driver. You will have to come down here and open this red carded switch from normal to cut off. So this is for all Boeing 737, 747, 757, 767, 777 and 787 aircraft. Then you use only the manual trim switch over here. You use the manual trim for the horizontal tail of the aircraft of the Boeing 787 for trim up and trim down the horizontal tail, as you can see. Also we have the pitch stream over here, the alternate channel of the flight control computers, so we use also that. So you can see here we have the primary flight control computers. since this is a fly-by-wire aircraft, same like pretty much to the Airbus function or the Embraer. So you can see from disconnect to auto, flight control surfaces. So we have many things to see in the overhead panel, many functions. So we use when we move the flight controls, the yoke, the control column for climb or descent, or the control wheel. This is the control wheel that controls the ailerons and the spoilers, the rolling axis. This is the pitch axis, the elevator, and the yawing axis, the vertical axis, the rudder pedal. So we give a signal to the flight control computers to move to control all the flight controls you see around. But they are actually hydraulically actuated. So you will see also we have another function of the flight control system. We have the speed brakes here, extend and retract, manual extend and retract. You see the speed brakes, extend, retract. This surface, you see also the flaps and the slats over here, which increase the surface area of the wings and the lift ability of the wings. So you can see how many degrees you want them up. 0. Over here you will see they move up. You move them down. You see now it's moving 5, 10. Now you move them down to extend position like this. So you can see how many degrees you want them to extend, like 20, 25, 30 degrees out, fully extended. So you will see how many degrees you fully extend the flaps and the slats over here. You see they keep extending over here. The flaps are fully extended both sides. There is no asymmetry of the flaps. So we have also other things to see here. We have the left and the right tensing, thrust lever. We move using the side stick. We have the auto throttle disconnect switch. You disconnect the auto throttle like this. Auto throttle disconnect. You can see also auto throttle disconnect, takeoff, ground, thrust reversers. You pull up and when you are in the landing, touchdown or reject the takeoff, and you move in the idle, pull up this funnel. So you have also the fuel control, right, left and right over here. We have the fire extinguishers, left and right tensing, pull out and switch, the transporter, the rudder trim over here. So this is the radio communication panel, radio management panel. We have also a few more things to see here. We have the mouse pad. We control the cursors over here, like this. You can see this is a mouse pad over here. So we can control the function of the displays using the mouse. Electronic displays. We have also the keyboard, the alphanumeric keyboard. So this is the mouse that controls this function of the Boeing 787. Also, you can switch over here and display some things with the digital format with the mouse. So make some selections. So we have a few more things to see before going into takeoff. You will see the flight controls, more full version of the flight controls. Also the flight management computer. So I'll show you another view now of the flight controls. So I'm the outside view. A couple of minutes only. We need to complete this function. So I will show you how to control using the side stick, Logitech the Steering 3D side stick. That is mainly for the Airbus aircraft. Also I can control the flight controls of the Boeing aircraft, of the Boeing 787-900, the yoke, the control wheel, rudder pedals, and the thrust levers, the horizontal trim, stabilizer, the flaps, slats, and the speed brakes, the spoilers of the aircraft, the flight spoilers. So you can see again, the side stick deflection is proportional to the yoke. Both sides are interconnected. So you see the flight controls movement, also the outside. so you can see another nicer view maybe. So we have also this view over here, so you can see, maybe the screen is looking better now. So you can climb and you can descend like this using the elevator. So you see I'm using the side stick to control the elevator for climb and descent. Also the ailerons and the spoilers for making left and right turns. The rudder pedals. So we change the direction of the aircraft as we fly like this. We have full flight controls control. So hope you like the way we control the flight controls of the Boeing 787. With the side stick, horizontal trim stabilizer, also the thrust levers. We move the thrust levers forward and aft. So we have the full flight controls in flight. So you can see here again the outside view, climb, descend, make turns left and make turns right, rudder pedals here. So you have full flight controls like this, quite easy, quite natural. The side stick deflection is proportional to the yoke, flight by wire system. Horizontal trim stabilizer, you can trim the horizontal tail, and thrust levers function. You can control the engines like this. So that's I believe all the flight controls. You can see both captain and first officer are moving together. They're interconnected. In fact, they don't have the side stick priority. Like in the Airbus, you can take one side priority at a time, left or right side in the cockpit. So hope you like the side stick I'm using. You can see. So I'm gonna show you now the inside, the flight management computer, the autopilot flight director system panel, and the overhead panel. So we'll start now with the flight management computer. I will input the data of the aircraft for this flight, the takeoff gross weight, that includes the empty weight plus the parts, plus the cargo, plus the fuel on board, where the fuel is stored in the left and the right wing, how much we have, 30% in the left wing, 30% in the right wing tank, and 10% in the center tank. So the flight management computer is going to calculate the center of gravity of the aircraft. During the whole flight we're going to burn fuel, so the center of gravity is going to be shifted and recalculated. Also, this will give us the mean aerodynamic chord position of the forward wings, the stall position using the mean aerodynamic chord, where the maximum aerodynamic lift occurs in the forward wings. We have also the stall, so we need to monitor the stall. Over here in the airspeed tape, we have also the stall displayed when we fly, with a red and yellow indication, yellow and red below the airspeed. We need to keep an airspeed above the stall when flying. So we're gonna calculate, we're gonna use flaps 15 degrees and also the horizontal trim stabilizer 4.25 degrees pitch up. We're gonna trim the horizontal tail of the aircraft for flying from takeoff. I'm gonna use the runway we're gonna use for takeoff, runway 14 in the Zurich International Airport. The runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air and the temperature of the air. And this will give us the takeoff speed V1. We rotate, we're gonna have a pitch attitude of 9 degrees rotation and about 140 knots for V2. plus 15 knots for takeoff with 15 degrees of flaps. So you're gonna see how we're gonna do that. We're gonna have the seats, the solar instrument departure waypoints and fixes, that include horizontal vertical navigation fixes for the initial climb of the aircraft and altitude and speed constraint. You're gonna climb to the cruise level at 35, 26, 27, 28, 29, 30,000 feet above the sea level. Then we're gonna cruise and transverse through some waypoints. We're gonna have the top of descent. We're gonna descend back to the airport elevation, like 6 or 7,000 feet above the sea level. For approach and landing, we're gonna have the stars, the solar terminal, arrival waypoints and fixes, that include horizontal vertical navigation fixes and altitude and airspeed constraints for the terminal approach, the long final and short final of the aircraft in the airport. In the runway 14 in the Zurich International Airport in Switzerland, you're gonna see how I'm gonna align with the magnetic north pole heading of 136 degrees for this. You're gonna have about 9 degrees of pitch attitude for approach and landing, about 35 or 30 degrees of flaps, and 160 170 knots of airspeed. Landing gear down. We're gonna have also the Lszh localizer, the horizontal localizer, and the vertical glide slope, and the Lszh localizer crossbars, as I told you, that receives the radio frequency transmitted from the runway. We're gonna use for takeoff and for landing. It's gonna align us with the magnetic north pole heading of the runway 136 degrees. So you're gonna see how we're gonna use the horizontal and vertical localizer, the Lszh localizer or instrument landing system. We have to tune the Lszh localizer frequency either automatically or manually. So we're gonna go over here in the flight management computer now, control quadrant. So you'll see one more display here. So you can see the functions I told you. We have the mouse pad to control the cursor here, the keyboard also. So we have the functions here: identity, position, performance, takeoff, approach, and on-seat status, navigation data, flight plans, load aircraft control, load plan, save plan, identity, Boeing 787, 900, Iraq cycle, index position. So we have the reference position, Lszh airport, Zurich International Airport in Switzerland. GPS gonna give us the coordinates. It's gonna align, so we can have more functions like performance here, the fuel on board, takeoff, gross weight, altitude. We're gonna cruise, so we're gonna set this later after I set the route over here. So I select the route, Lszh, the origin, departure, airport, back to Lszh. Over here, copy paste. So clear that, and we have the runway we're gonna use for takeoff. Runway 14, we're gonna use the same for landing. So we have the departures. Over here, departures, we can use runway 10, 16, 283, 2, 14. We're gonna use the runways over here on the left side for departures, and the seats, the solar instrument departure waypoints and fixes. So we're gonna use the runway runway 14, Zui to Alpha, the seats, departures, arrivals. Then we have the arrivals here. We can select runway 16, VOM 28, 34, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28 or localizer 34. So we have all the approaches available. So we're gonna use runway ILS 14, instrument landing system, trans, Amiki, trans a waypoint in flight. You're gonna see how we're gonna do that. And then we're gonna select the stars, the solar terminal arrival waypoints and fixes, Negria 1 alpha. So we have the legs here created, the legs of the waypoints, one waypoint by another. It's gonna create the purple line you see, the flight plan. So we cancel here discontinuity, we connect all the lines together, make sure from takeoff all the way up to cruise, then descent, approach, and landing. It's gonna give us the airspeeds, the altitude constraints, airspeeds. So we select zero fuel weight, fuel on board, gross weight for takeoff. So we have 322 plus 34,000 pounds, gross weight 357,000 pounds. So we cruise at 25,300 feet above the sea level. Cost index 100%, reserves 5% is gonna give us a fuel freezing temperature. Over here you can see minus 37 degrees in flight. The fuel will freeze, as you can see. Cruise center of gravity, also we can have the step side flight over here, cruise flight, altitude, performance, fuel on board, zero fuel weight, reserves. So this is we press the execute, now it's gonna give us the purple color, so we have activated the flight plan. So this is the first waypoint, 2 nautical miles, 250 knots, 1900, same heading like on the runway intercept. Then another one, TRO 96, then another one, we have Zui, 6 nautical miles, 301 knots, 6000 alpha. You can see the distance from one waypoint to the next one in nautical miles over here as you fly. Then we have the top of climb, 26 nautical miles in area, 301 knots, flight level 22,200. Then Mative would change direction, make a right turn, 12 nautical miles, 320 knots, 11,800. With descent here, we start the descent. Amity 109 knots, 10,400. Z 180 knots, 7,000 alpha. Z8 186,000 alpha. So this is the stars here, the southern terminal approach, waypoints and fixes. 108 knots, 5,000 alpha. CI 108, 4,000 alpha. Olsen 4,000, 170 knots, 5 nautical miles, 8 nautical miles. Runway 140 knots, 1,430 feet. So we use also over here the flaps for takeoff, 15 degrees of flaps. You can see in the takeoff reference, center of gravity is going to be calculated automatically when we select the flaps. So this gross weight and the takeoff speeds in this runway position. V1 128, V rotate 130, V2 140 knots. So this is the flight plan created. Departures, arrivals, alternate, VNAV here also. You can see other functions that we have in these buttons. Progress over here, FMC communications, hold, we can hold in a waypoint here in flight, fix, and navigation radio. So we stay with the legs here for the flight. I'm gonna show you a little bit the cockpit now, a few more functions that we're gonna have that make the engine start demonstration. So you will see also the indications now, the display, primary flight display, our displays. We have also the display of the flight plan created here, the VOR ADS navigation aids, just like in the original aircraft, everything created, ADS left, ADS right. So we have the takeoff from this runway, climb, cruise, descent, approach, and landing. You can see also here the vertical profile is going to be flying. The display come closer, you see more detail in the waypoints that we have selected, like this, even by waypoint. This is approach and landing. Also here, when we fly over here, when we fly the furthest away waypoint. So here is the Amity, here is the Negria and Amity. As you can see, Matic, all three of them. How far away we're gonna be flying using these waypoints here, one by one. Also in flight, you can see from climb, cruise, descent, approach, and landing. Will give also information to the autopilot flight director system panel. You can see here is Germany, here is France, here is Switzerland, displayed in the map. You can see also the vertical over here. We have to fly using the aircraft elevation right now. In front of you, you can see the mountains with the yellow and green and red display. Also is higher. The green, you can see the runway. We have the taxiway in front of us and the other runway. Like you see the taxiway here, you see the taxiway here on the runway. Used for takeoff. Also from outside view, the terrain, also the mountains that are displayed in front of the radar display right now. So we have a few more minutes to go for flight. For navigation purposes, the plan here. Oh, we have a bigger one. Display, setter also. The plan over here. You can see map centering over here. So we see a little bit closer the waypoints with the plan display over here. Oh, we have also the airport Lszh here displayed. Big stop location. You can see from takeoff here, this is the takeoff climb over here, this purple line. Here is the descent and approach. We have also the cruise over here. I'm gonna cruise when we climb over here, make turn and come back for landing. So this is the main components of the flight plan. The map display, also the plan over here. You can see more airports further away from you. The name of the airport. So we come back here in the star navigation display. When you'll be flying, you can see also the other side. You're gonna see now the engines, left and right engine. We have the N1, which is the low speed starter sub low pressure compressor and turbine of the turbofan engine, left and right. 90.8%, 99.6 the takeoff limit, green, red, yellow, never exceed. Exhaust gas temperature per engine, temperature Celsius, and 2, which is the high speed starter sub, the highest pressure and compressor and turbine of the turbofan engine, left and right. Fuel flow per engine per hour 1000 kilograms, 1000 pounds, 1500 per engine per hour right now, in thousands of pounds. Oil pressure here, oil temperature, quantity, vibration, so 1000 pounds. We have flaps, horizontal stabilizer here, rudder trim, some other functions, takeoff, gross weight, total fuel and fuel temperature right now. Some warnings, we have the standby display here, landing gear up and down, extended track, alternate over here, alternate gear, lock override, the switch, and we have also the auto brake down here, eject the takeoff, or 1, 2, 3, 4 maximum for landing. You can deactivate if you press the toe brakes, the auto brakes, if you don't need them. So we have also a couple more things to see. So I'm telling you about the engines. We have the pressurizer also from the left and right engine over here, cabin pressurization, manual. You see the outflow valves indication. Also we display over here a couple of information about the outflow air from the engines, left and right engine, cabin altitude, rate of climb, descent, differential pressure, and landing altitude. So we have a few more minutes to go for this flight. So you will see also the autopilot flight director system panel. We're gonna set over here the systems. Autopilot engage, disengage, the airspeed over here. You can set the airspeed whatever you like, and also set the LNAV, the VNAV. So we have the auto throttle also left and right over here, auto throttle left and right, on and off. This switch, we have the flight director. If we turn off the flight director here, it will deactivate the modes arm like this. We cannot rearm them, or the autopilot. We need to have the flight director on all the time like this. So we can dearm the VNAV. So we have VNAV, LNAV, VNAV, which takes the information from the flight management computer. Flight level change, climb continues, auto throttle, autopilot engage, autopilot disengage like this. Bank angle in flight, bank altitude, heading, we can change the heading, like North Pole heading reference over here, 136 degrees. So we have also the altitude, set the altitude here, thousands of feet, how many thousands. We're gonna be climbing 35, and 1, 2, 3. So we're gonna set 35,300 over here for the altitude. We have the roll localizer and the approach throttle on the other side. Also zeros, level on off. This is the vertical rate of climb descent. So you can descend like this, or you can climb like this. The other way, you see the plus sign now. So you see the plus now indicated. So all these indications now display in the head-up display and also in the primary flight display with purple. The heading of the runway, the airspeed selected, the altitude selected, the vertical rate of climb over here with this purple needle. Let's localizer in the headings. So we have a couple more minutes. We need here to start the APU right now. I'm gonna start the APU like this. So this is gonna start the auxiliary power unit in the tail of the aircraft. We need to start the engines. So I was talking about the engines. We have the FADEX that display all the engines data, the full authority, the electronic control computers, the FADEX that control monitor to display all the engine totals in the upper and lower ACAS, and the indication equivalent system display. Like the N1, which is the low speed source of low pressure compression tube and with the two perform temperature engine uses has temperature per engine. The N2, which is the high speed source of the high pressure compressor and tube and with the two perform engine, the fuel flow range per 30 kilograms, 1000 pounds for the pressure or temperature of quantity, and the vibration of the N2 stage of the engine. The FADEX also control the outflow air from the 5th and 9th stage of the engines, compressors that supplies the hydraulic fluid tanks, pressurization, also the wing and engine on the ice, air conditioning and ventilation, cabin pressurization, oxygen regulation in the cockpit and the cabin, also for as I told you, hydraulic fluids. So when we move the flight control, we need the hydraulics. So it takes pressurizer from the engine, also the landing gear, parking brakes, stars, reversers, flaps, slats. You see all the flight controls move here around. So we need the hydraulic pressure, also the cabin pressurization system. As I told you, the FADEX also controls the circulation of fuel from the wing, left and right wing tank and center tank to the engines to heat up the fuel in flight so it won't freeze. Also the fuel, also the lubricant and the oil. Also the FADEX control as we climb the aircraft from the sea level all the way up to like 20, 30 or 40,000 feet above the sea level, like 8,000, 9,000, 10,000, 11,000, 12,000 meters above the sea level. The pressure of the air, the oxygen level and the density of the air become less than half than that of the sea level. Also as we climb higher, the temperature of the air becomes freezing, like minus 30, minus 40, minus 50, minus 60 degrees below Celsius, below zero. And also the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level. So we're gonna have a higher intake of air from the front fans of the engines for compression and combustion. This is control also the fuel air mixture request is gonna be different as we climb from the sea level all the way up, or vice versa as we descend back to the sea level. So we have the FADEX, the full authority, the electronic control computers to control everything for the engines, also engine start, engine shutdown, fuel air mixture. So it's a good thing to have the FADEX installed into your engines. So you see start the APU, we have the left and right IDG, the great drive generator, left and right engine driving the battery, primary flight control computers here in the auto, heading reference, air data computers, flight control surfaces, FD, towing power, FD door, passenger oxygen, window heat, rammer turbine, left and right engine, hydraulics, engine driving and electric driving. We turn off and see what happens. This effect, the full display. So we turn back on and to the auto position. So we have also here the recorders. We have the APU and cargo fire extinguishers. We have the engine, electronic engine control, normal and alternate mode, and the auto start. We're gonna start the engines later. You can see how fuel jettison will get down some fuel to lose weight and make an emergency landing here. If we need also the nozzles, we have the fuel on board, left and right wing fuel tank, center tank, balance, crossfeed valve. We can use the crossfeed to balance the fuel between the left and right wing, or also to feed either engine with other pump or either tank. wing and edging on the ice over here. The lighting system of the aircraft, the windshield wipers, also the pressurizer, the packs from the engines and the APU. We need to follow the systems. I told you, cabin pressurization, when climb descent, half fuel valves, manual, auto, we need nothing to do. So we have a couple more minutes. We need to start the engines. So you will see how we're gonna do that. Make an engine start demonstration. So I will show you the last thing here, the digital display of the systems. Just before flight, you will see hydraulics here, APU, oxygen, liquid cooling, the electric, as I told you, left and right engine, IDG, 120, 200 volts, 400 Hz frequency, the battery voltage here, load cell, battery voltage and average. Hydraulics, when the hydraulic fluid goes, left and right engine driving, electric C1, C2, pressure 5100 psi, start of valve, fuel on board, left and right wing, center tank 11,000, 11,000, 11,000 total, 33,500. Alone high pressure fuel valves open and feed both engines from the center. The APU is fed from low fluid using the DC motor. You can see also the crossfeed valve is off, but we turn it on. You can feed either engine with either pump or either tank. And also we have the fuel booster pumps, or balance the fuel between the left and right wing. So you can see here the minimum fuel temperature, below which the fuel will freeze in flight, and the temperature right now of the fuel. So we need to recirculate the fuel into the engines to heat it up. So we have the pressurizer, the packs here, the doors are closed, the cabin can be pressurized, the gear, the pressure of the tires and the pressure of the brakes, flight controls here. So you see everything is working when we move around this thing here. The flight controls movement, also the tail, horizontal stabilizer, F is display, maintenance, system, circuit breakers, and the last thing here, system menu, the checklist, normal menu, what to do before, like before start, after takeoff, descent, approach, landing. So we go back in the navigation display, we turn off both engines like this. We have only 1 minute left, so we turn off both engines like this, left and right fuel control to be off. You will see what happens here. We have off the engines. Let's look out. We need to restart very quickly the engines of the Boeing. So we go over here, the overhead panel, start the auto start, both on. You will see yellow reconfigurations in the overhead. So you see now we have pressurizer from the APU. It's gonna accelerate the engines, pressurize the engine starter. So you can see here the roaring of the engines. So we need to start the fuel flow now. Fuel control on both engines on, like this. So we're going for takeoff in 1 minute, or less than 1 minute. So we have the auto start 29% over here, 32. 44. So all the systems are ready. Auto start almost complete. At about 60%, 61, 62. We have both engines running. So we use flaps now for takeoff. With brakes retracted, parking brakes off, and we go in for takeoff. We take the runway clearance. Advance the thrust levers here. So idle thrust for alignment. The taxiway, the runway is open for us. For takeoff, we take the runway clearance. So we taxi to the runway heading. Over here, as you see, align with the runway. So we use takeoff power over here and go. So we hold down the yoke a little bit as we accelerate until 100 knots, a little bit right rudder right now, left rudder. So we have 130 V1. We rotate slightly, like 9 degrees, as you can see, 9 degrees rotation. So we have the positive attitude, positive rate of climb over here. Landing gear up as we're climbing, and we have a few more minutes. As you can see, a few more minutes for flight. So you can see the displays, what they display. You can see the airspeed. We are 2,400 above the ground, 4,000 feet above the sea. We climb with 5,400. The pitch altitude, the terrain around you, the terrain here below you. You can see the aircraft is like 3,000, 4,000 feet above the ground. Over here displayed. Also further away we look. You'll see the red, green, yellow indication of the terrain. You can see the terrain map in more detail. So we keep climbing, as you can see. We have here the Switzerland, beautiful view, the lakes, the Swiss Alps, and the airport here as we depart. We need to make the turn now. So we're gonna make a turn over here. As we're flying back to the flight plan, I'm gonna cruise through some waypoints, then come back for landing. So we align here. So this is the view after takeoff of the airport, of the aircraft actually. The airport is this way, you can see on the left. We'll make a small turn here. You can see we can fly with the hands off the side stick or the yoke. The aircraft keeps following its flight path, there's no problem. So we look outside again. A nice view over here. So we need to come here. Let's see how we're gonna align this route here. So we have the beautiful view again from outside. Also, we're gonna overflying the lake here, and the Germany and the France. So we have a few more minutes left. So we have 12 more minutes left for this flight. Gonna keep climbing, as you see. So we have 10 more minutes, almost 12, for the flight to complete. As we keep climbing, gonna cruise through some more waypoints over here. So this is the Zui, next one is the Negria. Gonna have to reach this point. So now is the Negria, as you can see, switch the waypoint to the next one. You can see also the head-up display, also the autopilot here, the other side of the cockpit, and we have to start the turn now, I believe. So we are very close to my homeland Germany. In front of you, Bayern Munich, the lake, the Switzerland here, the Swiss Alps, the France, the Italy, this side. So you're gonna see we have to start the turn now. So we begin the turn back for the airport, because we only have 10 more minutes for this video to end. As you can see, we want flight close out to the lake. This is close to Germany, Bayern Munich and France. So you can see. Also the Swiss Alps, beautiful view as we turn back to the airport. We need to use a little bit right rudder, and we have 9 more minutes left. You can see we follow all the flight plans here for alignment and for going back to the airport as we climb. So here we are, again a nice view as we reach 23,000 feet, 29,000, 22,900, 23,000. You can see also the wind direction here and speed, the distance range here. The airport is located here pretty much as we can see in the map, and we are here. We're traveling this way, so we have a few more minutes to go. So we're gonna having the chemtrails now. Here they are, the frozen vapors, as you can see from the engines, from behind the engines. Also the galactic view of the aircraft, the lake behind us over here, beautiful lake, the Germany, the France. So we're gonna be having to start the descent now to the airport. As you can see, flaps up, idle thrust also, and we have 6 more minutes left to go over here. So keep descending, and we have a few more minutes left to go for approach and landing. 6 more minutes actually. So now we are descending. We are in a good point view over here. We have a beautiful view of the cockpit again, the instrument, the panels. You can see we're flying manually. There's no problem with that. Keep descending. We need a faster maybe rate of descent and follow the waypoints here, the flight run, as you can see. Also the waypoints, engine thrust idle, as you can see now. So keep descending, and we have 5 more minutes. You can see the terrain map here. Need to follow. For instrument navigation purposes, so we're gonna use a little bit more thrust to get faster over there. We are descending. We're gonna have the airport displayed very close to us. You can see also here. And we have 4 more minutes left for approach and landing. Gonna start the turn in a couple of minutes. Silent thrust now again. Let's start the turn now. Keep descending. So we're gonna use a little bit left rudder during the turn, also increase the rate of descent over here. You see the turn that we take over here. And we have 3 more minutes left for approach and landing. We need to align with the airport center line, as you can see, for the final approach and landing. Use a little bit left rudder again. So we have a few more clouds here, as you can see, leveling off whenever we need. Make some turn again over here, and we are aligned almost here with the runway, as you can see. We need 2 more minutes left to land the aircraft, so keep flying. Landing gear down, flaps extended. So you can see here. So we are aligned for the landing part over here, as you can see. We need to descend a little bit more. Also, we have the Lszh localizer. The runway is in front of us. As you can see descending. Flaps fully extended. We have also the Lszh localizer here, the instrument logic system, all the indications we need to follow. We are aligned with the runway, the center line. So we have some side wind to combat from time to time, a little bit left and right. Flight controls, a little bit more thrust. So we have some wind gust. We need the rudder pedals for align. Then with the wind gust and a little bit more thrust, as you can see. We have a bit more airspeed. Align with the center line again. Wind gust. Flight controls. We almost close our for the flare of the aircraft. We're gonna have idle thrust, rudder pedals again. So here's the flare. We're gonna have a nice, very nice flare here and touchdown, as you can see. So here's the flare, beautiful flare and touchdown, very beautiful. So parking brakes and thrust reverse to the idle, thrust reverses over here. So we're slowing down. We made a very beautiful landing, very beautiful, and we're slowing down, align with the runway. As you can see, all flight controls, the rudder pedals. You can see the landing gear and the nose wheel are pretty much safe. There is no breakage, and we've made a full